All right, next question. All right, so we've got a jar that contains marbles. There's 4 red marbles, numbered 1 through 4. There are 6 marbles, numbered 1 through 6. 6 blue marbles. All right, and then you're drawing a marble from a jar, and we have to find probability for each of these events. All right, so let's take them one at a time. So the first condition is we want to find a marble that is red. Well, there are 4 red marbles. Okay, so let me give a notation here. So probability that you're picking a red marble is 4 red marbles, okay, out of the total. So how many total marbles are there? There are 10, right? Because there's 4 reds and 6 blue. So that's it. So our probability of picking a red one is 4 out of 10. Now that can be reduced to 2/5. Okay, we'll enter it in a second. All right, the next problem wants us to find the probability of picking a marble that is odd numbered. Okay. All right, so let's look at this. So we know we've got 4 red marbles. They're not square, but they're numbered 1, 2, 3, 4. And we've got, let's make these our blue marbles. And then we've got 4 red marbles, numbered 1, 2, 3, 4. Okay. What is the question? The question is to find the chance of picking an odd numbered. So we have odd numbered marble, odd numbered marble, odd, odd, and odd. So altogether, there's 5 odd numbered marbles, regardless of the color, out of the total of 10. So it's a 1/2 chance of picking an odd numbered marble. Okay, the next question is picking a marble that is either red or odd. So let's see. Okay. So let's start over here. All right, so let me draw this out again. So we have 4 red marbles. We had 6 blue marbles. Oh man, that is 1, 2, 3, 4, 5, 6. All right, so let's figure out how many of them meet the requirement of being either red or being odd numbered. So we've got a red, a red, a red, and a red. And then we've got an odd numbered, odd numbered, odd numbered. And we got another odd numbered, another odd numbered. However, we're not going to double count the marbles that we've already accounted for. So altogether, distinct marbles that are either red or odd numbered, there's 1, 2, 3, 4, 5, 6, 7. 7 of those kinds of marbles. So again, so these are my odd numbered ones. And these are my red ones. However, because I already counted the red ones that are at 1 and the red one at 3, I'm not going to count them again. So 3 plus 4 gives you 7 total marbles out of 10. Now, another way of kind of thinking about this mathematically is to think of it this way. So you have 4 marbles that are red. So your chance of picking a red marble is 4 out of 10. You've got 1, 2, 3, 4, 5 marbles that are odd numbered. Okay. However, we're going to subtract out the overlap, which is 1 marble that's red and 3 marble that's marble 3 that's red. 2 out of 10. And so since denominators are the same, we can just add the 4 and 5, subtract the 2, and that's how we get the 7. Okay. So 7 out of 10 is the probability there. And in the last question, the marble is either blue or even numbered, so same kind of idea. Let me erase this here. So let's count the number of blue marbles. 1, 2, 3, 4, 5, 6. Okay. Blue. And then count the number of even numbers. So far we got 6. Now these are also satisfy the 2 and the 4. However, we're not going to double count the 2 and the 4 and the 6 that we've already included in the blue count. So altogether, distinct marbles that we have that are either even or blue are 1, 2, 3, 4, 5, 6, 7, 8. So all the ones that I have a check mark next to. So the probability of picking one of those is 8 out of 10. Yeah. Or 4/5. Okay, so let's check our work. So we have 2/5 was our first answer. 1/2. Then 7/10. Okay. Two out of 5. 1 out of 2. 7 out of 10. And 4 out of 5.